So when it comes to cable design, the cable manufacturer plays a very particular role in the whole process. The engineers and the designers, they get very familiar with the applications of their design. They know the environment that it's going in, they know signal or voltage or all sorts of technical aspects of it. But there are certain ways that those things translate to the practicality of a cable assembly. And bringing all of those things together can oftentimes be more complicated than it seems. There might be a series of specifications that just unfortunately are incompatible. And we know that's not something that every customer is expected to know right off the bat. And that's where your cable design manufacturer really comes in handy, because with the industry knowledge and business relationships that they have all over the industry, it makes it a lot easier to navigate those design considerations. Another really common design error that can arise is over-engineering and aspects that are not utilized properly or fully in a design. There are times when we will see a specified cable that comes with a foil and a braid shielding on it, but it is not connected to ground. Unfortunately, a shielding is not going to be effective if it's not connected to a ground somewhere on the assembly. And at that point, it's just adding unnecessary bulk, unnecessary cost, and it could be substituted for something that doesn't have that shielding and oftentimes may very well perform better than the previous option. So it can just be important that if something is specified on a drawing, there is some rating, really considering what value it brings to your assembly and if that is a necessary design choice. When designing a cable, a very important design consideration is the wire and terminal pairing. Usually, your terminals will have a gauge range that is compatible with them. Usually, it's within a couple points. You'll have your 18 to 16 or your 18 to 22 gauge, but it's not usually a very wide range. Now, sometimes we'll come across a situation where a terminal and a wire, while within the compatible gauge range, doesn't actually fit. Usually this is a case of a larger insulation than is necessary for the terminal. Terminal has two different crimps on it. It has the wire and the insulation crimp. The wire crimp goes around the inner conductors and ensures a strong and electrically sound connection, while the insulation crimp attaches to the outer insulation of the wire and ensures a mechanically sound connection, so that additional strain is not put on the wire crimp and you are not breaking any strands. The issue can arise, though, where the terminal has a specified outer diameter limit that it can accommodate. Sometimes when you specify something like UL 1015 wire, which comes with a larger voltage rating, but it also comes with a larger insulation diameter. Now, you might be specifying a wire that is on the larger side of the gauge range for the terminal. And unfortunately, that additional thickness in the insulation diameter of the UL 1015 wire can actually put that wire out of spec for that terminal, regardless of the fact that the gauge actually should be compatible. This is something that is not usually immediately communicated on maybe a spec sheet for a terminal. You will go look at it and it will specify the terminal gauges, but unless you are out there looking at the drawings and double checking the diameters and you're looking at wire specifications, it can be a very complicated process to figure out, but it is just a very important consideration to really think about, as things are not always what they seem when it comes to wire gauge ratings. Dimensioning can be a very important aspect of cable design, whether that is specifying so that you have enough length or you're trying to meet a space requirement. Your lengths and your tolerances can be very critical in some cases. Now, particularly tolerances can be a very difficult place for engineers to find something that is manufacturable easily or cost effectively. The IPC 620 specification specifies anything less than 1 inch have a tolerance of -0 or +1 inch. Now, that tolerance doesn't work great when you're dealing with a 2-inch assembly. That's a 50% tolerance in length that if you're dealing with very limited space requirements can just not be possible. So we often advise customers that if they are never sure what tolerances to specify, a common rule of thumb is generally the bigger the better. Anything over an inch is going to be overkill, as you very, very rarely are going to have that much variability, especially with the kinds of toolings that we personally use and the level of detail that we build everything to. We're never going to get more than an inch, even if we're given it. That being said, as you get smaller, it can be very difficult to find what is enough. The general rule of thumb that I like to tell customers is, again, the larger the better, but if you have to get smaller, keeping it to a round, more simply measurable dimension is very nice. Whether that be like a ½ inch or a ¼ inch or something that is a very easily understood decimal, or just something that is not a super difficult to read fraction. Not everybody is going to know the decimal conversions for 5/32 of an inch. So we can accommodate those, but it's really important to consider the time and the effort that it's going to take in your assembly and really weigh that against the value that that tolerance is providing. Because as they get smaller, the precision increases, efficiency is reduced, wire cutting machines have to reduce speed. People who are applying heat shrinks or labels will have to be much more careful and take a lot more time to make sure they are getting those right on the dimension. Again, this is something that can usually be accommodated, but if it's not critical, it's best to be avoided. So a very common sentiment that I personally subscribe to is that you should not pay for features you don't need. This is something that I tend to touch on a lot in a variety of different aspects of cable design. When you get those increased ratings, you don't necessarily get an improved quality in some applications. Something that has a super high heat tolerance might have a reduced flexibility that might impact your design. So in that case, the higher rated material is actually giving you a reduced quality assembly overall. So it is really, really important to really evaluate all of the specifications of every part of your assembly, understanding the environment that the assembly will be in, the electrical components of it, just every certain aspect of it is going to have a level that you need to meet. And the closer you can get to that without going wildly over that, you're going to have a better design overall. In the process of trying to ensure that your design is not overspecified, the best way to do that, and the common wisdom, is that you should start with a wide pool of materials and really narrow it down, starting with the most basic essentials. What is your voltage requirements? What is your temperature ratings? Do you need it to be flexible? Getting these really broad stroke ratings out of the way can really help you pare down to only the essential parts. This is kind of the inverse of going from a bottom-up method where you find something that meets every single one of your needs and start removing unnecessary aspects of it. It gets a lot more difficult because you kind of find yourself in a hole that you don't know what you need to remove to really open up your options. So just starting as wide as possible, cast a very wide net and start just eliminating the unnecessary components. So all in all, there are a number of different opportunities to make design mistakes in your cable assembly. There are so many different ratings and aspects of cable assemblies that I would not expect anybody to know every single one and to master every single aspect, especially when cable assemblies might only be one aspect of the design they're working on. And so this is a really great place that we like to offer our expertise and really help optimize this design to avoid these mistakes and make this the best design possible. So please never hesitate to reach out to your cable assembly manufacturer. I am always happy to help customers with their design and improve it in any way we can. My name is Devin. Thank you so much for your time and have a great day.